Assalamualaikum and good day, student. This video will discussing on the dynamic balancing, or in another word is a multiple plane balancing. So what we have here is what is a dynamic unbalanced situation. We have let's say a rotating drum. The drum is rotate at a certain angular velocity. So the drum is actually have a mass A located at the outside of the radius of the drum, and also mass B located outside of the drum over here. So basically the mass A and mass B will create a centrifugal effect. But when we are referring to the distance between mass A and mass B, so actually the system is having a moment or couple effect. So that is a couple effect acting at the system itself. When we are looking at view XX, by right we are having the system is in static balance because of the mass is, like say, the mass A and B, like say mass A and B over here is in the same mass. Let's say this is 100 grams. Let's say this is 100 grams. So by looking at view XX over here, so the system is actually in static balance mode, but not in a dynamic system because of it create a couple or a moment effect. Let's consider this figure. So we have the centrifugal effect to the mass A and B over here, and then what we have, if let's say we are considering the distance between masses, okay, this is the distance between masses. So we have this dotted line over here. So this is a reference plane, let's say. So this is a reference plane, let's say. We have a distance from A to the reference planes. For A is LA, and from mass B to the reference plane is LB. So of course A will create a moment or couple the mass, the centrifugal force, times the LA, the centrifugal force of B times LB will create a moment or couple. So the moment of couple will this is the amount, the magnitude of a moment created by mass B. So this is moment B, which is mass of B times radius. Radius is the distance from the mass to the center of rotation, times the omega. Omega is the angular velocity. Omega squared is the angular velocity. So L is the distance from the B, or from A to the reference plane. So this one we are considering about B. So we times the LB. So what the system tend to have is mass A is tend to move to create moment upward, and B will having a couple or moment downward. So the system tend to vibrate, obviously. So the system is in the unbalanced mode. To further understanding that one, we refresh back on the previous video where we have a four blade, I say, with the mass A, B, C and D with the same mass and the same radius. So what we have here is the vector of the centrifugal force of A, B, C and D. So we have to make sure that the system is in the balanced mode by constructing the force polygon. So we have the system over here is actually in a closed force polygon. So confirm that this is a balance in static mode. So what about the same blade, the same four blade, whether it is in dynamic balance mode, by considering that the system is been located, I mean the blade is been located at a different plane. Just now it is in a single plane, but now the blade of A, B, C and D is been located at a different plane. So each is been located 1 meter offset to each other. So A to B 1 meter, B to C is 1 meter, C to D is 1 meter. So from this figure and from this arrangement of blade, so can we say that the system is balanced in dynamic modes? So same thing happen. We need to construct the moment polygon first, because it affecting it reflects to the distance between A, B, PC and CD. By constructing the moment polygons means that we are dealing with the moment, the mr omega squared times the L. Okay, let's say we are taking plane A as a reference. We have to take any plane over here as a reference plane to understand the moment polygon, how the moment polygon looks like. So here we take plane A as a reference plane. So what we have over here, so means that plane A will having no magnitude because we already take plane A as a reference plane. So the first moment polygon will start with B. Since the distance is 1 meter, so we draw one vector over here, followed by moment polygon of C. Because of the distance from A to C is 2 meter, so the magnitude will become double compared to the B. And then followed by D, moment that created by mass D. Since the distance from A to D is 3 meter, so the magnitude of moment for D is 3 times compared to B. Okay, let's see the moment polygon. Now it is in open loop, so meaning that the system is in unbalanced mode dynamically. In dynamics it is unbalanced, so it is dynamically unbalanced. So how to solve actually the dynamic unbalanced system? So there is a two method. Actually there is a graphical approach and analytical approach. Since we are dealing with a moment, so we have to draw the closed moment polygon first to achieve the dynamic balance. Then only you have to draw the forced polygon, then ensure that you are achieving the closed forced polygon. In analytical approach, what you have to do is you have to do the amount, the total amount of moment must equal to 0. So you need to break it into x component and y component and solve the needed equation. After you complete the moment equation, and then same thing, you need to solve the force centrifugal force equation. Then you need to understand that the total centrifugal force must be equal to 0. Then you complete it by subcomponent of x and y. So basically that is the idea on how to do dynamic balancing for multiple planes. Thank you very much.